All right, like I was saying here, ne? Addition reaction, it is the reaction whereby you are converting double bonds or the showing or the single bonds. This one key addition reaction. You will check your reactants. Reactants ki over on the right, and then I check out the product. The product ki over on the reactants ki over on the left, and then product java on the right. But I check out the product okay. So ko mana reactant, a double bond, and then a product a single bond. Therefore, what that's about that one is reaction is an addition reaction. We have several types of addition reaction we can look at. The first one or leveling the hydrogenation. On hydrogenation, we have hydro, it comes from hydrogen. So hydro comes from hydrogen. We are adding hydrogen gas. We will be adding hydrogen gas. And the reaction condition for that is what? PTPD or lead and nickel as what? As catalyst. Check the reaction condition saying hydrogenation. Now let's get to the reaction. Now we have this one as an alkene double bond. It will react the hydrogen gas. It will react the hydrogen gas and then to form what? To form this one. So check the hydrogen gas 1, 2, 3, 4 from the original product, and then from there ra era kaing ka the hydrogen gas ttpedi ke ka mo ileng re dirang re breakile them the double bonds showing or the single bonds. So now we go to the next type of addition reaction. The next type of addition reaction that we'll be looking at is what we call the hydration. So not the hydration, hydrohalogenation. So this is the type of reaction like one first hydrohalogenation. Hydrohalogenation. All right, let's continue now. So hydro comes from hydrogen, halogen comes from halogenation, halo comes from halogen. So it means that here we'll be adding what? We'll be adding a hydrogen and a halogenation. We start by having what? We start by having the double bonds. Double bonds, and then from there we break these double bonds. To single bonds. Enga go just stories sa ilong ra onya go sekwane ka South Africa ge ba tšela batlhaki ge ba fa a ke re re tlo edantwela like ba thoma ka go tšela batlhaki, one bread one family wa bona ka re ba thoma ka go tšela batlhaki mara ge ba fa ba thoma ka go faing ba humi gore tšhelete ya mmušo ge etla e fa ba humi pele. Why am I doing this scenario? I'm doing this scenario so that you can understand that gore ka hydrohalogenation in order to form what? In order to form a major product. In order to form a major product, we must follow what? We must follow the Markov. We must follow the Markov-Nikov rules. We must follow the Markov-Nikov rules. So what does the Markov-Nikov rule? Erela gore ref agre ka addition reafa. Erela gore refa ba tlhake pele, right? Refa ba humi pele go re ba tlhaka. Refa ba humi pele. Re ba fa the hydrogen. Markov-Nikov o bolela gore in addition reaction, in order to form a major product, the hydrogen must be given to the carbon with the most carbon atoms. So now we are going to break this one. There you go. 1, 2, 3, 4. And then we have single bonds now. We have single bonds. This one. So this one. So what are we going to be distributing here? We are going to be distributing the hydrogen le the halogen. This one can be hydrochloric acid. Why bona ke re add le the alkenic. So now the hydrogen, according to the Markov-Nikov, in order to form the major product, we must follow Markov-Nikov. In order to form minor product, we follow Markov-Nikov. You understand the major product, we follow Markov-Nikov. Minor product, we follow Markov-Nikov. So re tlo lebelela ga carbon 1 le carbonic. Ke feng carbon e leng gore ena le di hydrogen tse dintsi ke carbonic. So ye kena le tse pedi, ye kena le 1. Gore this hydrogen will be placed here. And then this chlorine or halogen will be placed here. And then this one. So this is what we call the addition reaction. And then this one will be what will be our major product. Every time we reform a major product unless stated otherwise. This one becomes our major product. Addition reaction, the type of addition reaction ke hydrohalogenation. Be careful, add wabo ina le 1 ya balenteng. So the reaction condition there must be what? No water. Reaction condition there must be what? No water or unreactive solvent. So moka solvent let's move on to the next addition reaction. Let's move to the next addition reaction. The next addition reaction the next addition reaction hydration. So hydration, what are we talking about? You need to hydrate. Meaning what? In this case, hydration re-add metsi. Reaction condition excess water. Let's have this one. 1, 2, 3. 1, 2, 3. And then in a double bond more. And then we have this one, hydrogen. We have this hydrogen. And then we have this hydrogen. There it goes, hydrogen and then hydrogen. It will be hydrated. Hydration is the reaction in a link made H2O. And then this one reactor, it will form 1, 2, 3. And then from them, since we are breaking addition, we are breaking the double bonds. Every time addition, we are breaking the double bonds or rebelling the single bond. Now, if we go so now, let me draw the hydrogen chaka. 1, 2, 3, 4, 5, 6. According to Markov-Nikov, the hydrogen it will be bonded to the carbon with the most carbon atoms. Carbon 1, 2. So you can only 1. Hydrogen is bonded, and then there you go. Hydrogen, and then the hydroxide group it bonded. Meaning that hydration we are reacting alkene water to form an alcohol. Hydration. Every time when you hydrate, and then if ever break the double bonds, and then you must always know that the reaction condition for this one, the reaction conditions for this one, the excess H2O rabaling the small amount of acid. The small amount of acid there na ile gore na go lona keng e tla ba the sulfuric acid not sulfuric, yes, sulfuric acid SO24 go ba eng e ka ba phosphoric acid H3PO4 as catalyst. Check e ba eng in this case e ba tsona e le gore re dia gore keng ke the acid as what as the catalyst. Now that's what we have ka addition reaction ya rena ya bobedi. Since we should discuss the hydrogenation, hydrohalogenation, le hydration. So, go shota eng go shota e re bitsa gore ke halogenation. Halogenation. So now looking at this one, re discuss halogenation. So this one, for halogenation, hydro. It's just the reaction of what? Of halogenation gases. So now we are going to be reacting what? Let's take our double bonds compound. There we have our double bond compound. So it's going to react with what? This double bond compound is going to react with, since halogenation, this double bond compound is going to react with a halogen, any halogen. But in this case, let's take an example as what? Al2 chlorine gas, like this. So it can be any halogen, meaning that ngabe X2. It can be any halogen gas. So now we have this one. It's going to be reacting to form what? A single bond. So guys, the single bond because I know it's addition reaction. And then the hydrogen on the other side. There we go. So now, since we are adding here, it means that this chlorine, since chlorine it will bonded here, rabaling Cl, rabaling Cl. And then this one becomes our what? Our product, halogenation. This one becomes the product, the halogenation. Language, guys. And then, Moki, I want to follow Markov-Nikov. Why I follow Markov-Nikov? I guess follow Markov-Nikov because the only time you follow Markov-Nikov, the hydrogen must be bonded to the carbon with the most carbon atom. And in this case, we don't have any what? We don't have any hydrogen as what? As part of the other reactant. Hydrogen mo, maramoka the hydrogen. So this one is what we call halogenation, guys. Bonam. In most cases, sorry, before I conclude this one, let's go to let's talk about the reaction conditions. The reaction condition halogenation. This one you can say unreactive solvent. Any unreactive solvent, it can be what? It can be the reaction condition here. Generally, let me summarize, guys. Let me summarize about addition reaction. So in addition reactions, you start. We have 4 types of addition reaction. We have 4 types of addition reaction. Discuss hydration, and then we have what? Halogenation. We have halogenation, and then we have what? Hydro